To all present here. We are going to start with fourth day of this workshop today. And in today's discussion, we'll be talking about classification case study that we'll be conducting with a data set I have already shared in your WhatsApp group. I hope all of you might have placed it at your PC or laptop so that it can be accessed easily throughout your session. So there will be few things that we will repeat as we have done in yesterday's session, such as libraries and data loading processes. And then there will be many new things also that you may learn as a machine learning enthusiast today. So for this, the dataset as well as the code share file, I have already shared with all of you. That code share link you can use to get your codes side by side. I'll be sharing my screen with all of you so that we can start together for another hands-on session. Okay, so I'll be starting with Colab platform again, same as what we have used yesterday. So if anyone has not used it in yesterday's case, you can simply search for Google Colab on your web browser and go to the first link that comes from Google itself. Just log into your platform that you might have done yesterday also. If you are using it from your PC, it may not ask you to sign in because it may have already taken your sign in from the Chrome Windows. And then we'll go to the file option and we will open new notebook in Drive. So I hope that all of you know these steps. We have discussed this in yesterday's session also. So in the same pattern, we will open up a new notebook in Drive. However, if anyone still needs any help to open this new file, they can let me know in the chat box. I'll try to be responsive in the chat box side by side. So here I'm just renaming my file. You can put it as per the project name that you are going to do today. That is classification analysis with heart disease dataset we'll be doing here. And for that only, we'll be setting up different background elements as well as we'll be doing little bit of data analytics and ultimately we'll be building a machine learning model here. So a step-by-step approach again will follow today. And to conduct this, the very first step, as we know from yesterday's session, it will be same. That will be to import necessary libraries. And we will import the similar set of libraries initially that we have used in yesterday's session also. So it will start with importing NumPy as NP. Then we will import pandas as PD. And similarly, matplotlib dot pyplot as PLT. And next we'll have is Seaborn as SNS. So these libraries, I suppose you know from yesterday's session also. We have used them already. So I'll just run this portion and all of you can do the same. I'll share this portion of code here in your code share window as well. So the library process as well as data loading process will be same as we have done yesterday and you should get a green tick over here. You can quickly let me know if you are able to run these libraries and your platform is all set. I'll wait for responses in the chat box if everyone is able to do this. In order to learn it in best possible manner, try to practice side by side. Sit with your laptop and computer for all these hands-on sessions so that you can learn better. I'll wait for responses in chat box. If anyone is stuck anywhere before this execution also, they can let me know. I can help. Make sure you put all your troubles or doubts related to this session in your chat box. I'll try to address quickly. Okay, great. Thank you for update. I hope others are also doing the same. I cannot see any more responses. I'll just assume that everything is fine on the other side. If anyone is stuck anywhere, let me know. So the second step we'll do is to load dataset, and this will be also the same as we have done in yesterday's session. So I'll take one data variable, and into this I'll read my CSV file, that is read underscore CSV. So irrespective of what type of data you are using, like if it is in organized in a CSV file, these processes will stay the same even if you are using data from other domains also. Whatever we are doing here, the process is almost same for different domain data also. Just your objectives may change. Your objective for data analytics, your objective for target variable, that may change, but majority of things stay almost same. The pipeline generally you build like this. Some add-ons and some reductions may be based on your objectives only. So at least learn these case studies first. They will help you to set up a foundational block that how we actually implement machine learning procedure, so that this knowledge you can deploy later on with other type of data sets also. So in order to load your data, you first need address of your file, and that we will put in the file section here first, as we have done in yesterday's session also. So from the left side menu here, I'll go to the file section, and here I'll upload that heart.csv data file that you all have. I hope all of you know this process now. Either you can use drag and drop or upload button, any of these you can try. I can just click on this upload button, and I have this heart.csv file on my desktop. I'll just take it, click OK for any kind of warning if you get on your screen. And because this is a small data set, so this will quickly be available on your this below sample data set portion. So now I can just hover my cursor on this heart.csv file, right click, and then copy path. So inside this, I'll just paste this path, and then we can check first few lines of data. That will be first 5 lines by default. So head command I can execute for this, and we can see this is ready now. So all the variables available in our data, that is for prediction of heart disease cases, that is available. So some patient vitals, some general symptoms, they are already reported in this particular file, including age, gender, uh, and other pain types, etc. All of those variables are available here. Now, you will also observe that the data set here is not purely numerical. Rather, you have mixture of variables. There are numbers, there are some object entries also. You may find floating point numbers also, as well as whole numbers. All kind of data variables are present in this particular file. Okay, I'll wait, no problem. Let me know if you are able to execute up to this, or if you need any other help, then also let me know. I'm putting this code in the meanwhile in your code share window. Execute this and let me know. If anyone finds that I'm getting little fast, you can interrupt me anytime in chat box. I'll go slow at your pace so that you can learn better. Let me know whenever you are ready up to this. Yes, we are trying to display first 5 rows by default, so that is fine. I'll wait for a few more responses. Okay, great. I hope others are also able to do this. I can see very few responses in chat box, but I'll just suppose others are also able to do. Now, let us observe few essential details about your data. And the very first technique we will use is data info function, same as yesterday, because we are currently just observing data in the same pattern as we have done yesterday. So you can observe here that we have 918 rows in this data with index value starting from 0 to 917. Then there are 12 different columns in this data, and the structure of those columns is present in this section. You can see the names of every column, data type of every column, and then the non-null value, where null values we cannot identify anywhere, like this is also a clean data. This is a kind of synthetic data set which is already clean. In real time, generally you don't have clean data set, you get some missing values also. So in tomorrow's case study, I'll try to use one data set which has missing values. So there I'll also tell you that how you can deal with missing values in that case. But when you are using some kind of synthetic data sets, because in healthcare getting real data set is little difficult for general researchers, if until and unless you are into core healthcare domain itself, where you are collecting data yourself in the institute, in a medical health institute, then only you can have a quick access to data. Otherwise, for interdisciplinary research, it generally gets little difficult to get directly patient data to process. So majority of time, the beginner researchers start with some synthetic data sets, like I'm using one here just for the quick analysis, so that you can at least understand the pattern, and later on the same technique you can deploy on real data set also, because the structure is generally the same. Just some additional missing values or wrong entries, etc., that kind of pre-processing is additionally required. Otherwise, the processes are almost similar in other cases also. So we can observe here that this is a clean data set with 918 observations in total. And even there are some ways to identify exact count of missing value. Although in our current data set, there are like no missing values available. But if you have, there are possibility to check that also. Like I can mark here, check missing data, for example. So for that, what you can do is data dot is null function is available for that. And we combine it with some function. Observe what we are doing. Data is my variable in which my original data is stored. Is null function will test wherever there are any null values or empty values, or we can call missing values. But this in return always give you Boolean outcome, that is yes, no, or true, false, we call basically. So the output of this is null function is true and false. So wherever it finds a missing value, it will return true. Wherever it finds no missing value, it will return false at that positions. So when you have a bigger data file, like with these 918 observations, it will be difficult to track that position of true. And we generally do not try to locate the specific position when we are working on data science. We basically try to remove those values as a whole from a certain variable. So we try to get some of missing values in respective variables only, so that we can put a direct strategy to deal with them. And there are plenty of strategies that you can use to deal with the missing values. Sometimes we try to simply impute missing values using mean, median, or mode values, that are statistical values of your variable. Sometimes we try to impute them by using either previous entry or next entry available in your data. So in medical domain, several times the patient vitals are copied from the previous entry, and the same value is kept. That technique is also followed in medical domain very commonly, because maybe if you are calling a patient maybe 4 times in a month, but they are visiting only 3 times, so one row will be completely empty because they are not coming to visit in that area. So many time what students do in medical health domain, they just copy the same readings that were in the third visit into the fourth visit also, or sometime based on the domain expertise or recommendation of experts, they copy next readings into the previous cell. So all these kind of practices are followed in various domains, but this kind of decision generally depends on domain experts. So if your supervisors or you already have experience in dealing with patient vitals, you know that how the variations may go. So based on that, if previous or next values are fine, you can follow that also. For that also, direct techniques are available in Python. You can follow a specific function for that, and it will automatically find previous values and insert that into missing rows. However, sometime we can use based on statistical measures also, like we can calculate mean, median, and mode, etc., from the respective variable and use that to fill your missing values. And there are some algorithms also available for this purpose. So in extended versions further, you can learn about algorithms also. Currently you can observe that it shows 0 for all the columns, because currently we don't have missing values in any of the columns. So this is a clean data set. That is why we are getting a 0 here. In tomorrow's session, I'll try to incorporate something with missing value. So on that, if I run this particular variable, this particular function, we will get exact value of missing entry in these areas for that. So that observation will be highlighted that there are this number of missing values available in your data. So I have shared this section also into your code share window. You can run this and get a quick idea about missing entries in your data that you may need whenever you are working on real data sets. Now, next entry I'm making here is check value distribution in data, because we have multiple variables here. So if we want to just observe how different values are distributed in each variable, for that also we have specific function available. For example, I can deploy an unique function for this. What it does basically, it will check unique values in each variable. So when I'm deploying this, it will go through all variables available in data function, data file, and from there it will check how many unique values are present, and a count of that will be printed. So if I run this, observe, it shows values for all variables available in our data. So there are 50 unique values from age. There may be repetition. So just unique values only it will find. Then for gender, there are two types of entries that will be male and female. Then for chest pain, there are four different types of chest pains listed in this data. Then resting BP also we have like 67 different entries, because this is a kind of continuous variable. This is also continuous variable. So a large number of values you have. These are categorical variables, so lesser number of classes you will have. Then cholesterol, this is also a continuous variable, so large number of unique values you will find. And for the remaining variables also, you will find these kind of distributions. These are common distributions found among different variables in data. So I'm sharing this code also in the code share window. Execute this and let me know in chat box if things are clear up to this. I'll wait for responses in chat box. If you need me to repeat anything, then also let me know. Okay, great. So from here, now we can have a quick idea. First thing from this data, we should know that there is one target variable. For example, in second day of this course, you have already studied about classification and regression analysis. So that completely depends on your target variable organization. So in this particular data set, this heart disease is your target variable. That generally goes with your objectives that you have defined. In this particular data, the objective is to check whether the person is suffering from heart disease or not. So based on that, these zeros and ones are listed here. Zero represent a healthy condition, one represent person suffering from heart disease. And all these parameters are showing how different patient vitals and conditions are contributing to healthy and unhealthy conditions. So currently our main focus is this heart disease variable, and all these features are contributing to make that decision. That is your initial design of study that we are considering. Now in these studies, you will find that we have all combinations of categorical and numerical data. So whenever you are conducting a study with mixture of variables, you may first need to convert these variables into numbers, because machine learning models generally need input in the form of numbers. So for that, transformation techniques we follow, like I have discussed yesterday also. So similar kind of many other techniques are also available to convert them into numbers. But before that, what we will do is we will try to do some pattern analysis on this data, because whenever you are conducting certain case study on data, you also need some supporting documents. You need some pattern analysis. You need to check relationships between different variables that may somehow contribute in your decision making. So one by one, we will do that analysis here. And for this, I'll insert one more section. I'll write here exploratory data analysis. In data science, we call it EDA. This is a very popular term used in data science, EDA. This helps you to analyze all different variables available in your data and the relationship between variables, existence of individual variables, multiple things you can check within your EDA. So this is about exploring patterns in your data. Currently, depending upon the time available, I'll try to explore at least few essential variables in this data, and later on you can check other variables also when you do practice further. So first task that I'm doing here is to check distribution of target variable classes, because we know from the target variable distribution itself that this is a classification type variable. If you remember the discussion that you did on the second day of this course, that if the target variable is in the form of classes, it becomes a classification case study. That is why today we are talking about classification case study, because target variable is organized like that. So based on this, first we will try to check distribution of both these classes available in your target. And there are several ways to do this. I'm trying here one simple technique. I'll choose this heart disease variable from my data. This thing we have learned yesterday also. In order to select any specific variable, you can just put that within square brackets and inverted commas with reference to your main data variable. And then I'll try to check value counts out of this particular variable. That will quickly show the distribution of variables. This kind of thing we have studied, I hope, yesterday also, when we have observed that how transformation is helping you convert one variable to other form. So this will quickly highlight how many distributions you have. So in category 1, we have 508 observations. In category 0, we have 410 observations. So these are quick outcomes you will find from heart disease data. I'm putting this code in code share window also. You can execute this and get this number-based analysis. But for instance, when you have you are conducting some research problem based analysis, and you need to present these numbers in maybe some uh, PowerPoint presentation, or maybe you need to put these numbers in your some documentation, or maybe in thesis reports. Generally these kind of numbers do not make much impact, especially when you are putting that in PowerPoint presentation. Writing numbers is generally not good. So what we recommend, you create charts or some graphs for easy analysis or easy display. So we can create for this kind of distribution, that is your uh, categorical or class type distribution. We can choose a count plot or a bar chart. Those are common things we can use. So for instance, I'll insert one more code here, and I'll write from SNS, I'll take a count plot, and inside this, I'll pass on x-axis your heart disease variable, for instance, and I'll run this. So you can observe a quick distribution for heart disease we can have here, which shows that category 1 has higher number of values and category 0 has lesser number of values. So in this way, you can better present these numbers for your PowerPoint presentations. Whenever you are analyzing different set of variables, you can use this kind of graphs. So by default, it will put your values on x-axis and count on y-axis, and you can see this comparative distribution between multiple classes. Let me know if you are able to do up to this. Okay, so I suppose others are also able to do this. If anyone needs me to wait, then also you can let me know. How to give chart for research paper? You can download this. This you can just save, right click on it and save image as. If you click on this, you will be able to save it as a PNG image easily. So you can put it anywhere on your system and then analyze this one in your research papers directly. I hope that helps. Okay, I'll wait for others to deploy this. Let me know when everyone is done with this. In the meanwhile, you can check value distribution for one more variable, like gender variable, and let me know what outcome you get. Check value distribution for gender variable in your data. You are not able to load heart.csv. Let me know which error you have. Can you paste your error here? Getting errors while you are programming is the most important thing. That means you are trying to learn something. So don't worry if any of you are getting errors. Just let me know, because whenever you are learning certain type of programming, diagnosing error is the most important thing. So whenever any of you get an error, so everyone get an opportunity here in this session, that if a error is there, how we can diagnose that. So you just share your error. I'll just show you how you can solve that. Just quickly copy and paste your error here in chat box. Okay. So you are doing it with Drive. Okay, you have placed your data in Drive. You have not pasted the last line of your error where the exact name of error should be there. You just pasted the starting portion only. There should be one last line there. The exact name of error must be written. File not found error, I think it is. So do you have your data exactly at this position in your Drive? You actually have your data or not? Have you placed it there? Okay, then please share your screen. I'll just stop sharing. Kindly share your screen, then I can locate it exactly there. You cannot do gender plot, that is not possible. There is nothing like a gender plot. We are doing count plot is a method. Count plot is a function. Gender plot is nothing. That is not a function. You just need to use right plot type, and then inside your data variable you need to choose your uh, variable name. So gender will be inside your data square brackets, and type of plot will be count plot. Okay, so you are taking it from Drive here. Just show me where you have this data in your Drive. So the name of file is hurt.csv. Why you are writing my data.csv? Your file name is hurt.csv, but you are writing my underscore data.csv. That will not work. Yes, rename this hurt.csv. Yes, run this now. Okay, next problem is, okay, show me the file option. You may have not attached your Drive right now. No, not this, not this. On the left side menu, the second last one is file. The second last one, yes, click on this. So your Drive is not attached right now. See, the technique I was showing earlier to attach your file. Yes, now you can mount your Drive. Connect Google Drive here. Permit access to this. Just click on connect to Google Drive. Connect to Google Drive. Wait for a second. It will take some time to connect. You can see the drive here now. Now your drive is connected. Your My Drive is also available, and your Hurt file will be also inside this now. Whatever file you have kept inside with the exact name, it should be there. Just run this. Your file is not exactly inside My Drive folder. Just show me your Drive window again. Is it inside certain folder or not? My My Drive, then Colab Notebooks. Have you created a specific folder inside for Colab Notebooks in My Drive? Check if there is a specific folder named Colab Notebooks. Yes, click on this. So you have your file here. Now right click on this herd.csv and copy path. Now paste this path on that place. Yes, paste. Now you run. It's fine. Now you can proceed ahead with remaining codes that we have shared in your chat window. Okay, coming back to the discussion that we were having here. If anyone else is stuck anywhere, they also can let me know. So many of you are creating plot for the gender details. That will be very simple. Observe here what I asked you to do. The very first thing I asked you to check this kind of count. So for that, I'll write here, like, you can take the same thing. Same thing you can take, and you just have to rename the variable only. For example, I'll put this here. And first you just replace this with gender, because previous case was for the heart disease variable. Now the same thing we are doing for the gender variable. So we will just replace the variable, and this is the distribution. We have higher number of entries in male category and lesser number of entries in the female category. Now the same thing we can have in a plot also, like the same count plot if you want to create. So I'll just copy this one and I'll place it after this code. And again, you just replace your variable name. Remaining all things will stay the same. Count plot is a technique. You cannot rename it with your choice. This is a technique that is already available in your library. You can change only variable name. So just change your variable name and you will be able to see it something like this. Observe this. If you are able to create something like this, let me know in chat box. Yes, I'll be coming to that part also. This was just a basic thing. I'll be coming to pie chart after this. First, let me know if all of you are able to understand the count plot initially. So the next thing we are doing here is creating pie chart for any variable. Like pie chart generally we prefer for categorical variable. So maybe I'm taking same gender variable for creating pie chart here. So this pie chart we will create with the help of matplotlib library that contains pie chart, pie function already. So we have already imported this matplotlib repository with PLT. So this same PLT I can use here to create my plot. What I'll do is plt.py. Name of the chart here is pie. And inside this now again I'll pass my specific variable, that is gender variable, for which we want to create entries. And inside this one additional thing I'll pass is value counts, because to create pie chart it first has to check value count in all available categories. Like here we have male and female, so the same thing that we are doing this here, because it needs to know first that how much distribution is in one category and in other. So inside this pie chart we pass this value counts clearly, and then we try to create this pie chart. So this is the basic version of pie chart we are getting, but we can have a proper percentage information also, like how much percentage in this category, how much in this category, and what category this blue is representing, what category this orange is representing. We can modify it with that value also. So let me show you step by step modification. This is the basic pie chart we have created. Now I'll modify it slowly. Observe the very first attribute of this pie chart function I have already shown you. That will be value counts of your respective variable. Currently it is gender variable. Now we need labels of this particular distribution. So observe here, these are currently labels of your distribution and they appear in index. This thing is currently index of your value counts. Observe, normally your variables appear on the same level. You can observe all of them are on the same level. So when they are appearing on the same level, they are normal variables. You can access them by using square brackets because they are normal variable in your sheet CSV file at that time. But when something appears like this, it is slightly below, count is appearing like a normal variable here. So in this value counts function, this gender is working as an index variable that contains name of both category, and this is a normal count is a normal entry that is representing some kind of data. So when I need information about labels of both these categories, how I can get is by just accessing this index value, because 725 must be linked to M and 193 must be linked to F in that case. So easiest way to do that is I'll pass here label is equal to, and inside this exactly same thing I'll choose. This same thing I'll pass with dot index, because with this it is getting your exact count. That is, only one variable is available, so that variable information it is getting. But now I need index of that value counts output. So dot index I'll write, so it will access index only in that case. So I'll run this and let me just check if I have any error. Okay, label. This will be labels. So now observe, I got labels. One improvement I made in my chart. Now one more improvement I'll try to make, that will be to get a percentage of both these sections, that how much percent of data is here and how much percent is here. So I'll make one more change here. After this, after comma, I'll add one more variable that we call autopact variable. And inside this, I can mention here the distribution of my, like I'll write percentage 0.1 percentage. This is a keyword we use to display the values in this section. So the values here we are trying to display in percentage. Observe, this first percentage and this second percentage, they are a part of index that is helping us to declare here that we will need one value after decimal. This F here represent float, and this 0.1 represent 0.1 or 0.1, anything you can write, that represents one value after decimal, and this last percentage will be printed as it is to show the percentage analysis. So observe what change will happen. Currently it is appearing like this. If I run this, you will see this value. See the percentage last one, and after decimal one digit I can observe, and this value is your exact distribution difference that it has found. Similarly, if you want to make it like 2 digits after decimal, then instead of 0.1 you can write 0.2, 0.2. So in that case, 2 digits after decimal will be presented in your pie chart like this. You can see 2 digits after your outcome are coming here. So this will improve your presentation in pie chart, and we can further enhance it by using different options. Like maybe if you want to remove this thing, this array description, you can write here plot dot show, so that only plot is represented, not that array information. So it makes a clear outcome here. If you even want to add a title to this, you can do one more task. Observe here carefully. I'll write plt.title, and inside this I'll write here male female ratio in dataset. So this will become my title. A simple English language sequence. You just access your library, then name of the function, and pass whatever information you need inside it. So now you can see this becomes title of your pie chart. So Python gives you immense opportunities to improve your graphs as per your requirement. Currently, I'm just showing you few options. When you practice it more, you will find many other options to improve representations of your graphs. Now, I have shared this code in your code share window also. Try this and get it done. Labels will be in front of this, in front of your pie chart entries. There only you get labels. Labels are representing these separate sections. We are not keeping them on the bottom. We need to keep them beside because pie chart is represented like this. For a pie chart, you don't need x-axis or y-axis, just your labels beside sections of your pie chart. Let me know when you all are good up to this. Your chart is coming fine. What you need specifically? Male female ratio label in the bottom. That is not label, that is title. If you are talking about this point, this one, male female ratio in data set, do you need this in the bottom side? This is title basically. This is not label. Labels are the ones that we are presenting this side and this side. So you may need to find additional settings for that, like in title itself. For example, for this you can always go to, like, you can search for matplotlib title attributes. These are some ideas I'm giving that you can try later on. Like, you can go to the official platform of matplotlib, and here you will find options. This is by default locations they are giving, like it will be available on which position by default, but you can change these positions also. Like, there are three possible positions: center, left, and right. Only these positions it gives you. So in that case, what you can do is you can add another alignment option also, like in which section I want to align my this chart variables. So for example, this location we will try, and I'll just take this, I'll pass it here, location variable. And for example, we will make it right. We'll just try which options it will accept. So it will just on the top only, it gives you option, like it is shifted towards right. And if I make it left, it will be shifted towards left. So by default, this gives on the top only, or you can give it on the center here. So accordingly, in the middle, it will come. So these minor changes it will allow with this current function. Otherwise, you may need to find pie chart function available in other libraries also. Currently, we are doing based on the scope of this session only, because we are considering basic libraries only. Later on, you can explore additional libraries such as Plotly, etc. They give you higher level interaction possibilities with your charts. So in that case, you can modify it up to higher level also. So in that case, you can update your variable positions as per your choice as well. I hope all of you are able to do up to this. Okay, great. So currently we were doing only single variable analysis. We call that univariate analysis also. Maybe you want to observe two variables side by side. So that is also possible. And for this also many different charts you will find. So currently, for example, I'll try to see maybe heart disease, that is target variable, versus gender variable, maybe. Both of them we want to organize side by side. Even a simple count plot can give you this functionality as well. I'll show you how. I'll go to the count plot. Then on the x-axis, I'll pass here data and heart disease variable. And second variable I'll pass is hue. And inside this, I'll pass my gender variable. So that on x-axis, the distribution goes as per the heart disease variable, and the color scale goes as per the gender variable, so that we can see distribution side by side. So with this, if I try to plot it, you can observe a comparative chart also we can create. Like what are the heart disease cases among males and females we are getting. So for the zero case, we have this, you can see male represented with blue, female represented with orange. So for zero entries, depending upon whether zero is representing your in your encoding, whether it is representing healthy cases or heart disease cases, so you can have both categories represented here. Similarly for one. So this will help you to analyze two variables against each other at the same time, and count plot is generally preferred for categorical type variables. In those cases, you can update that. Percentage you need for these bars. For the count plot bars, you need percentage.
Yes, ma'am. On the bars, if we can get how many percentage or
Ma'am, there are
male,
plenty of
female.
ways. See, currently I'm not exploring all the possible attributes inside a function. But every function has plenty of attributes that you can try based on your requirements. So we will not
Okay.
be able to explore all of them right now. But I'll give you one idea. If you want to explore it further, there is one possibility you can try. Like whichever plot you are creating, you just go to its official platform. You can see when I highlight it on my this platform, you can see all different variables get also highlighted side by side. So based on that, this, if you want to use any other option, like maybe any other parameter you want to fill in, all of them you can see here. Like stat information is available here. So stat is equal to count is by default value here available. So maybe if you want to check this, that what it does, I'll write here maybe stat is equal to count, for example, and I'll run this. Let me just check. Okay, this is stat. So currently this portion is coming with count only. But if we want to change this, like I'll just choose this count plot further. This is for your exploration that you can do later on. We will just check. We will just go through these parameters. Google Colab give you several functionalities easily. You can see in stat, you can have percent also. You can write it like this. By default, it is count, but I'll insert percent here. So accordingly, it will change its representation. So here, percent I'll get. So on the y-axis, basically, it has possibility to do that. So here, it is now in the form of percentage. If you need it right on the bar, then you have to explore with the Plotly library that we are not covering right now. Plotly is your advanced analytics library. So maybe in some advanced course, we'll try to do that somewhere. But yes, a quick, whatever possibilities are with the existing functions that you can explore like this. You can just highlight the function and you will see what are the options available with that function. Everything will be available for the parameters, and you can update them as per your requirement quickly.
Okay. Thank you.
Okay. So we have seen this with reference to two variables side by side. Now you can do this with many other variables. Like for pie chart also, currently I have shown you one way. That was with this value counts method. There are other ways also to create pie charts. For example, maybe if I want to create that for the chest pain variable, there is one chest pain variable also available. Uh, Create pie chart for chest pain variable. I'll use another way. That is, I'm just showing you for the reason that even to do a single task, there are 100 different methods in Python that goes with your compatibility, how you want to use one technique or other. So I'll just show you another quick way. This is a group by technique. It will group with reference to the variable that you want to use, like maybe chest pain type is one of the variable available in your data set. We will just evaluate size of this chest pain type variable. It will automatically check how your data is distributed in chest pain, how many categories are there, and in every category, how many values are lying there. Based on this, we can create a plot. So plot type we can mention is pyplot, and similarly autopact we will add as we have done earlier. So we will make it percentage 0.1 percentage, and we will just close this. So if I run this one, let me check. I missed some point here. Okay, F I missed to write. So I'll just run this, and you can see for chest pain variable, we could get a quick outcome. So this is another way to create pie chart. I'm showing this secondary option just to give you an idea that there are unlimited possibilities just for creating similar type of plot. And for every type plot that you use here as a function, you will have range of variables. The variables that I'm inserting here, they are just few examples. Later on, as you practice more, you will be able to find other variables also in this relation. Try this version of pie chart, and then we will move further with data transformations. That looks fine. Do you have any specific to ask in this plot? Your plot looks fine. Okay, great. So for example, if we go back to our variable sheet here, you can see that we have different variables organized here. For some cases, maybe you have any hypothesis or maybe your objectives that you are trying to clarify. Maybe you want to see that how heart disease is impacting different age groups. Maybe that is one of your objectives of study. So you have here age in the form of numbers right now. This is not in specific groups, like you don't have adult, elderly, or youngsters. You don't have a specific category based on that age. But for your objective, you can even create a new version of age variable that could be grouped into specific age ranges. So for that, let me show you a quick analysis what you can do. First, let us have a plot for your age variable to see its distribution. I'll highlight here manipulating age variable, considering some objective that you want to analyze heart disease cases with reference to age variable. So first thing I'll do here is I'll create a distribution plot. So I'll call it a dist plot, and inside this I'll pass my variable name, that is age variable, and I can see this kind of distribution. This is another type of plot that you can try. There are like 1,000 different plots you can create in Python. Currently just few of them we are observing here considering the time limitation. So maybe we are just looking at the distribution of age variable. And from here, maybe you got an idea that, okay, there are different number of observations in each category. Majority of observations are from this mid-range, from 40 to almost 65. You have majority of observations. Now, maybe further you want to analyze that what are the prevalent cases in all age groups or maybe you want to categorize it based on maybe any specific 3-4 categories of age. So for that, what we can do is, yes, definitely you can draw normal distribution curves also. That is possible with kernel density estimation plots. KDE plot, you can search for that. That is available in your Seaborn as well as in Matplotlib library. You can find that with both these libraries and you can deploy that. We call that kernel density estimation plot in Python. KDE plot, you can search for that. You will be able to execute accordingly. So currently for the age distribution, we have this range available, and inside this maybe you just want to get exact numbers. For example, maybe the start and end numbers first you want to know. So we can write here minimum value available in age. I'll run this, and maximum value available in age. For that also, I'll pass this here. So we got that minimum possible value in our data set is 28 and maximum is 77. That we can visualize from this distribution also. Starting point is below 30 and ending point is above 70. So this range is available. Now we want to categorize this age variable. As I have given you one objective, that maybe you want to observe your heart disease variable with reference to age distribution. So for that, what I can do is I'll put here the categorization technique. So a simple function I'll try to deploy. Function age range I'll create. Inside this, the variable will be passed as age, and then we will apply our condition. If age is less than 40, maybe I'll return the value as maybe young. Similarly, else if age is greater than equal to 41, or maybe you can use 40 also, so that it gets covered after this, because this will be less than 40 only. So 40 and above this we can cover here. And then age less than 60. Maybe we will call this one area as middle age, and then maybe the else category we will put as return elderly. So this is a way to create function. Those who have attended the previous level of this workshop in this series, they might be aware about function creation. We have discussed function creation part over there also, that how you distribute these conditions. But if you are doing it for the first time, this define keyword we use for defining age, any of the variable name. This is name of variable right now. This is the parameter of this function, that is age range function. Now inside this we are applying different conditions, that if the value of age is less than 40, we will call it young category. If the value of age is between 40 to 60, we will call it middle age category, and otherwise for the higher than 60, that will be naturally. So for that we will call it elderly. So 3 categories from our age variable we are trying to create. So I'll just run this. This is currently a function. A function need to be deployed. So earlier we have seen that your age variable was in the form of numbers. If you go up, you will see that this is available in the form of 40, 49, 37, that kind of distribution you have. Now I want to change this distribution to category wise. So for that, what I'll deploy here is I'll just use this same age variable. Note that I'm not creating a new variable. In yesterday's session, we have created new variables also. Currently, I'm modifying the existing variable only. So that is why I'm using same variable name before equal to. If you want to create a different variable, a new variable, you can change this name with some other like age group or age category. Then it will create a new variable. In my case, I'm just modifying the existing variable only. So we will just apply this function here that we call age range function. And then we can check updated data head. So you will observe now that age range function will no longer be in the form of numbers. Rather, it will be in the form of these categorical values. So I'll run this and you can see this got changed. So depending upon what values we had here, now we see updated age ranges. So now based on this, if you want to see some relationship with your target variable, you can do that. I'll not go back to the distributions. We are working on transformations right now, so I'll focus on this. But yes, you can create the plots again based on age categories, and that will help you to get your updated sequence. I'll share this sequence of codes with you now. So this plot you have already created. I hope these min-max entries you can do yourself also. These are just some basic codes only.
Can I ask you something?
Yes,
Yesterday
please.
you told us to categorize using bins. Can we use that method also here?
Yes, you can try any method. That is possible.
This
Just
age
we
group
are
is
analyzing different options. Otherwise, you
oh,
can try any technique.
okay.
So currently, this the entire set of code I have shared with you, just an option to update your variables we are trying here that you can use with different set of variables available in your data. We are just trying to learn the simple approaches or some alternative approaches only that you can use while formulating your data variables. Otherwise, as I am telling you right from the beginning, that there are unlimited possibilities in Python. So as you dive deeper into this technique, you will be able to learn plenty of other things also. Let me know when you all are able to get this age variable. I'll wait for a while as you get it done and let me know in the chat box after that. I hope others are also able to do this. Okay, great. So I'll just move forward. I'll not modify much variable, just one example I have given you. Depending upon your requirement, you can modify other variables also later on. So currently, what we'll do is, because we have to deploy a machine learning model also further, so we will spare time for that mainly here now. So before deploying your machine learning model, what you may have to do is, because currently you have data in mixed format, numbers are there and categorical values are also there, so we may need to transform them. So in order to transform, the very first thing we will do is we will separate target variable first of all, because we don't need to modify anything in target variable, that is already in the clean version. So I'll write here separate features and target. That should be our first task, to get a clean target variable separated. So I'll use here two variables, X and Y. These are generally the professional ways we prefer. X variable we generally use to represent features, and Y variable we generally use to represent target. However, you can use variable names of your choice. That will not be a problem. You can use any name. You can write here features, you can write here target also. In my case, we are just using the standard notations here that we commonly prefer for representing features and target. So the first case will be, I'll just drop here one variable. So I'll call it columns is equal to, I'll write here heart disease variable. So this I'll try to remove from my data. And in the second case, only this heart disease variable I'll keep. So for features, Other than heart disease, everything else I want to keep. So I'm just dropping one variable, that is heart disease. And in target, only heart disease will be kept, nothing else. So in this way, we can separate variables easily. Now, this one becomes your target, and this one becomes your set of features. We can call it a set of features. So all of you can separate your variables like this. Once you have separate set of variables, then we will just modify your input features. We will just encode them. We will just scale them down to get it ready for machine learning model building, because target is already in the encoded form. So we will use that as it is. We will not change anything from the target. So the next step I'll add here is separate categorical and numerical variables. Let me know what error you have. Not supported between instances of, you have run it twice. The only problem is that you ran this code twice. It has already modified your age variable, so you are trying to modify it again, then you will get an error, because this is no longer a number variable. It will not find this range inside already modified variable. So in order to get rid from this error, you have to refresh all your variables first, because currently you have already changed your sequence, so that will not work. So do one thing, observe on your screen, go to runtime and click on run all, and then wait for a while. All your variables will be refreshed and updated age sequence you will get. Let me know if this works. Just go to runtime and click on run all variables will be refreshed. Do not run any cell multiple times, especially when it is modifying your variable. Okay, great. So now we are separating numerical and categorical variables so that we can deploy different operations on them. As on the categorical variable, we will apply encoding techniques because we want to convert alphabetical sequences into numbers. And on numerical variables, because currently if you observe, they are very high scale variables. Like this one is having value somewhere between 200, 300 or 150, etc. This one is also having values close to 200, 100, etc. But this old peak is having very low scale values. Observe this fact very carefully. When we are training a machine learning model, if you have numerical variables with this kind of distribution, like some are on low scale, some are on high scale, like whenever you will be modifying these variables also, they will be on low scale, but these will be on higher scale. So if you train a machine learning model with this kind of distribution, generally these high scale parameters start dominating your remaining features. So what we do, we scale these features down. You will find reference for this technique in literature also. This is a trusted method that is followed by researchers over the years. And this scaling method is generally deployed in two cases, especially when your numerical variables have different units. Like the measurement unit for resting BP will be different, cholesterol will be different. So when there is a unit difference, then also we prefer scaling or normalization. When the scale difference exists between variables, so that the dominance of one feature on other feature can be avoided, that in that case also we do scaling or normalization. And what does it mean? We basically try to bring your variable sequence down to either a specific range or close to zero. Generally close to zero is the most preferred method, because that brings a central like your easy to process computations for machine learning models if the values are close to zero. So scaling down by default will help you to bring your values between 0 to 1. That is the preferred range. So they will be mathematically adjusted. Like for example, if you need to understand it more clearly, I'll write here on whiteboard. The scaling process and encoding process is very important to understand. Encoding we have done yesterday also, so that you know already. That is just about converting your variables from one form to other form. but scaling procedure goes with the numerical variables. So for that, for example, currently you have like 2-3 different variables in your data that include cholesterol or resting BP and some other variables also you have. So if one variable we call is like cholesterol variable, maybe the range of that variable is, I'm just taking dummy ranges only. Maybe it varies from 100 to maybe 300. And then we have some other variable like maybe resting BP is also present in your data. So maybe it is having values somewhere between maybe 70 to we call maybe somewhere around 100, 200. So maybe these are general ranges of these two variables. So they are on different scales, and also their units of measurement are different. So what we do technically, we bring all of them to same scale. So that scale generally, like there are hundreds of different methods that you can try, and you can also follow that based on domain expertise. So we generally recommend that you go with the literature of your domain, and then you see which methods are recommended in your case. But in general, what we have as a very frequently used method, we try to scale them between either 0 to 1 or -1 to 1. These two methods are most commonly used. Other than this, standard deviation and mean based methods are also available. So in that case, you calculate mean of variable first, and around standard deviation, you try to scale it down. So that is depending upon your requirements further. Currently, based on the time available, I'm just showing one technique only, like for example, scaling between 0 to 1. So in this case, if you try to scale down cholesterol variable between 0 to 1, so in that case, this 0 will be mapped corresponding to your lower scale value. We'll write 0 to 1 like this. 100 will be mapped to 0, 300 will be mapped to 1, and all intermediate values will fall within. Similarly, in second case, 70 will be mapped to 0, 200 will be mapped to 1, and all intermediate values will fall within. So you may have intermediate values that are statistically brought down. There may be a value like 8.9, there may be something 8.92, 0.42, 0.55. So many statistically scaled values will be there. So because this is a statistically driven method, so that is why it is trusted in all domains. But however, domain recommendations also you can consider in this, and for that you will have to go with the literature, and you need to find which scaling methods are preferred in your case. But I'm just for now I'm implementing this one for the scaling purpose. So the first task I have given you here is to separate your categorical and numerical variables. And for that, what I'll do is I'll create two different variables here, that is data.num and data.cat. This will be representing your numerical variables, and this will be for the categorical variables. Currently, I'm doing this in separate pipeline. Again, there are many other ways also to do this. Just one example I'm showing you here, that how you can separate your variables. So I'll write here select data types, and inside this I'll write exclude object. So we'll just exclude objects, and everything else we will put into numerical variables, because object represents your categorical variable. And in second case, I'll write include object. So I'll just run this portion, and it should bring your both categories separately. Let us verify first. I'll use here head with numerical data first. Observe, it contains only numerical variables now. And second, I'll take data underscore cat dot head, and it contains all categorical variables now. You can observe the ones that are alphabetical are categorical variables, the ones that are in numbers are numerical variables, and we could separate them in a single pipeline here. So all of you can do the same, so that we can apply different operations on them. Like the categorical ones will be encoded, and the numerical ones will be scaled down. We do not do encoding or scaling opposite way. They are dedicated operations for different versions of data. So I'll just share this set of code with all of you, and then you can check heads for both of them. Heads you can check yourself also. The main code I have shared already. Let me know if you are able to see these separate portions in your pipeline. I'll wait for responses in chat box.
How do we separate them, ma'am, in data head?
You just write this one, name of respective variable, and put head against that. Because now we have two different variables now, so you can access them directly now. Let me know what error you are getting. Okay, great. Those who are getting an error, let me know what it is. Let me know your error so that I can help. Okay, if it is working fine, then I'll move one step ahead. If still anyone wants to share an error, they can let me know. So first I'm doing here transforming categorical variables. So we will try to use same encoder as we have used yesterday. I'll not add one new encoder, but definitely we'll try that later as you expand further, because a same encoder is not possible in all cases. Again, you will take recommendations from literature that which method is applicable on your variable, and also depending upon whether your variable is nominal or ordinal in nature. Based on that also you select different encoders. For example, if your variable is ordinal in nature, then you will consider ordinal encoder, or you can consider label encoder. Those are commonly used encoder for ordinal data. If you have nominal data, in that case you can consider one hot encoding, that is, or dummy encoding. Those are commonly used techniques for nominal data. So sometime for different variables also you can use different types of encoding techniques, but here I'm just using one method. I have just given you a hint that how you choose, how you apply them separately, but deployment technique will be same. You'll just have to change name of a method, and deployment technique will be almost same in all cases. So here what I'm doing is, from sklearn pre-processing repository, I'm just importing label encoder, and then I'll just deploy it here with default entries, default parameters. So yesterday also we have done the same. Then I'll just try to fit it to create my encoded categorical data. So I'll write here enc fit underscore transform. Inside this, I'll pass my data underscore cat, and then I can see my updated version of data in head here. Let us see if this works. Okay, I'm getting an error. Okay, while transforming a data cat, we need to pass here the column details and also array sequence, right? That will be fine. So what I'll write here is fit underscore transform. Let me just update it once. I'll write here column names, that will be data underscore cat dot columns, and here I'll write pd dot data frame so that we get data frame in the output itself. Okay. Encoder is fine. Fit transform we are applying. Data cat is also fine. Okay, this one we will close here. Okay, let me try this with for loop technique. Maybe it will not work like this. Let me, like yesterday we have used for calls in data underscore cat, and inside this, I'll try to pass. Let me see if it works this way. Okay, let me just try. Label encoder is not fitting well into this version of data. I'll try ordinal encoder, for example. I'll write here encoder with ordinal encoder I'll pass, and I'll write here fit underscore transform. Inside this I'll pass data underscore cat, and then we will get the encoded outcome with pd dot data frame encoder. Okay, first I'll check it with the basic version itself. Yes, this is coming now. So with ordinal encoder, this data is fitting well. The other one was not being working with the current version of data. Maybe some modifications were required in that. So because we have limited time, so I'll not work on the modification of that. Just one other type of encoder I'm applying here, that is ordinal encoder. Currently, the output is in the form of array, but we need a data frame. Data frame appears something like this, like a proper Excel sheet. So I'll just recover this in the form of data frame. So for that, I'll take help from pd dot data frame. I'll just use the conversion here, pd.data frame. And inside this, we need to ensure that column names are also preserved. So I'll pass columns is equal to data underscore cat dot columns that I was doing with the label encoder also earlier, the same thing. So now the encoded version I can see. So this is the encoded version. And you can see that by default, this ordinal encoder is doing in decimal points. We can even control this. Like I'll write here data type is equal to int only, not float. So in that case, it will encode in the form of integers, not in the form of floats. So you can check it in the form of head also over here. I'll run this. So first 5 lines we can observe. So just one type of encoder I have applied here. You can try other encoders also later on, like different types of possibilities I have shown you yesterday also. The same techniques you can deploy and you will be able to see that your categorical variables are transformed. Try this. I have shared this code in chat box and get it done. Okay, this worked. Yeah, fine. That should work fine. You are using directly fit transform with columns for operation. That goes fine. So yesterday also we have done this kind of approach. That's great. So let me know if you are all able to execute this one. Now, in the similar manner, I'll use normalization of numerical variables or scaling of numerical variables. So I'll write here scaling numerical variables. And inside this, from sklearn.preprocessing, I'll import min-max scaler. This min-max scaler method by default scales down between 0 to 1 that I have shown you on the whiteboard also. So the by default approach in min-max scaler is 0 to 1 scaling. So first we'll have to deploy this with its default parameters. Like the same process will be there. What we have done here, the similar process we will do. Now I'll apply scaled data here. So for that, pd.data frame. Inside this, I'll deploy scalar dot fit underscore transform. Inside this, I'll put num data and then I'll pass data columns. Entire technique will be same, just method we are going to change to scaling instead of encoding now. So then scaled data head we will be able to check. So again, I'm creating a data frame out of this. So this technique will help you to create data frame. Otherwise, by default, it may give you an array. So depending upon your requirement, you can update. Now you can see this is your scaled data head for numerical variables. Earlier, they were available in this format, high scale value, but now they are all between 0 to 1. You can observe this one here, all between 0 to 1. So statistically, they are scaled down. So I'm sharing this set of code also in your code share window. Execute this, and then we will combine all variables back into single feature sequence so that we can feed them directly into your machine learning model, because there they will go all together, not separately. So just transformation pipeline we have created, and then we will combine them back. Let me know when you are done up to this, then we will combine these variables back.
Cholesterol needs to be in 5 digits, 5 or 6 digits. Is that okay? Or
this one we are using default coding right now. If you want to control it up to 2 decimal places, for that also you can put control here. By default, it will bring you down it up to 4-5 decimal places, because it tries to bring you the precise values up to larger scale. As here we have not added any other control parameter right now, no? So by default it will work in this format only. Okay, in the next step now I'm going to combine them. Combine scaled and encoded variables. So we will write it x new, for example. Then pd.concat I'll use here, and in this concat I'll concat scaled and encoded variables both. Make sure you have so we are just working on concatenation of different set of variables, and for this you need to use exactly same names. For example, one set I saved with scaled variables and other set I saved with encoded. So if you have given different names to the variable, accordingly you will update that. So in this case, I'll give them same name. And here one more thing I'll mention, that is x is equal to 1. This will ensure that the concatenation goes on row axis. Means these features get aligned across rows instead of coming up and down. So that first all these will appear, and after all these in column by sequence will appear, so that they align on same row sequences. So if I do this, after this I can check head of x new. Now you can observe they are all aligned across rows. So the first row, this first row is aligned with first row of this. So that kind of x is we have controlled here by writing x is 1. So now we could create final feature set that we can put inside our machine learning model. So it is important to mention here that whatever methods we are using, it is not like for every data set it will be exactly same method. Approach will be something like this, like some encoding you may have to do, some scaling you may have to do, but type of method will vary depending upon your objectives, variable distributions, and what decisions you are trying to make. Sometimes we increase features, sometimes we decrease features, sometimes we have to do feature selections, rejections. There are unlimited things within machine learning or AI. Currently, considering the scope of this workshop only, we are doing just few examples here. Later on, as you expand further, because AI itself is a very big branch, we are not able to cover everything in a single course. This is just a start point we are getting. At least you should know how the step-by-step process goes and how you can get friendly with the language here. Only that part we are able to cover in limited time that is available. So once your variables are ready, something like this, if they are ready in the form of numbers, for example, then we can update the next step, that is to build a machine learning model. And here, the very first step will be to separate your training and testing data set. If you remember from your second day session, you might have heard that we need to train machine learning model, and after training we have to evaluate it. So in the training process we use training data set, that is generally the majority portion of your main data, and in evaluation time we use testing data set, that is minority portion of your data. So I'll just separate it by using a simple technique here. In sklearn library I can go to model selection, and here we have train test split model by default available. You can try this. Train test split is directly available. It gives you 4 different outcomes: xtrain, xtest, that is your training feature and testing features. And similarly, you have ytrain and ytest. 4 things you get in output. And here you pass train test split. And inside this, x new is my recent feature variable, y is my target variable, and test size I'll mention, for example, 0.25, which means I'll use 25% of data for testing and remaining 75% data for training purpose. I told you that majority data goes for training. And then I'll add one more parameter, that is shuffle is equal to true, so that we can shuffle all the observations and they get equal opportunity to enter into training and testing data set. So in this way, these 4 outcomes we can easily find, out of which this training combination we will use to train data, This one we will use to make prediction finally, and this one we will use to evaluate how well your model has predicted. So all of you can create these 4 sections from your data now that we will use into model training finally. Let me know if you are able to create these 4 sections of data. Then we will move forward with the classifier design. So I'll deploy just one type of classifier here because we are already on the verge of session. I'll just deploy one of them. And in your theory session, you have discussed plenty of different classifier models. So later on, you can use others also. I'll just give you an idea how you can use other models also. So accordingly, you can try and deploy different versions. So currently, the process will be from sklearn tree repository. We will import decision tree classifier because decision tree classifier is a tree based model that you might have heard during your theoretical discussion also. This belongs to tree repository in sklearn. So from there we will call this decision tree classifier. Then I'll deploy this maybe with DCT name. I'll deploy this and I'll use default parameters only. So whenever we use a method with empty brackets, I told you yesterday also, it means we are using it with default parameters right now. And then I'll try to deploy it dct.fit xtrain ytrain. So this will ensure training of DCT model. Decision tree classifier is being trained at this step. Then we will make prediction. So prediction outcomes I'm storing in y predict. Means the predictions made by system for y target. And that will be dct.predict. And predictions it will make from testing features. So we will pass testing features here. And then we will compare predicted outcome with expected outcome to make sure that your model is performing well. So the comparison we will do with reference to certain matrices. Evaluation matrices also you have discussed during second day of this course. So out of that, just 1 or 2 I'll try. Maybe for example, accuracy score I'll use to have a quick judgment on your model. So from accuracy matrices, I'll import accuracy score. And then I'll just print this. I'll use here accuracy. And accuracy score function I have already imported. I'll deploy this. And this will compare between expected and predicted outcome. So y-test was your expected outcome. Y-pred is your predicted outcome by the model that we are getting from here. So let us see how much accuracy we are getting from this model. This is showing 80% accuracy. Not very bad, but not very good also. So this is just an initial version of model we have deployed here. You can take this. You can see in theory, you study so many things behind any model, but Python makes it easier to deploy. You just have to call your model from respective repository, initialize it. Currently, I'm not tuning model. Model tuning is another advanced level process. We are not covering that here in this particular course. So model tuning generally takes several days and several months because in that case, you have to tune the hyperparameters of a model. There are plenty of hyperparameters associated to every model that you can find also when you highlight it. So you can see these are hyperparameters of model. The default values are available here. You can observe further values also. You can just go through here and there are many other change options that you can apply to improve your model performance with time. So that goes with the second level. Once you have learned the basics, then you go further with hyperparameter tuning. Currently, we are using the basic version. That is fine. You can get different accuracies also because decision tree, if you remember the theoretical portion, it will create its own tree. So if all of us are deploying a decision tree on the same data, then also it is possible to get different results at initial level, until and unless we have not tuned a particular model to get a similar outcome every time. So in that case, that tuned model only you have to deploy everywhere, and then it will give controlled output. But currently in our case, we are using just a default version of model, so its initializations may be different on all CPUs. Accordingly, it may give slightly different outcomes also. Let me know
Previous,
if you all are able to deploy this.
no, ma'am, before decision tree classifier, from
Mhm.
there error is coming. I don't know.
On this point,
Even before that, from that error
which portion
continuously.
here?
Yes,
What error you are getting? Just let me know. What is the name of error?
I'll show you.
Sorry for the background noise. Some people are celebrating around, so I cannot control that.
From this scalar, no, not scale, scaled head, BX new.
Scale head. This one.
1 minute, I'll show you.
Just paste your error first. Just let
Okay.
me see your error. Let me know where it is occurring. Okay. X new is not defined. In that case, your problem is here. Have you run this code cell?
Yes, ma'am. Whatever was there, I ran. Maybe
Okay.
VX new, I have to run. I have left it.
Yes. You need to run each one of these. Then only it will work. First try this. If it still doesn't work, you can share your screen. Now run everything after this also.
No, even the previous one also is error.
Now share your screen, please. Let me check.
Okay. These are.
You have saved it vxnew. The variable name is xnew. So this v, it is not able to identify. Check. Remove this v.
Okay.
Yes. Then run it again. Now run everything after this.
Okay. I'll do.
Okay.
Stop sharing. Thank you.
So now we have deployed final model. I can just wind up at this point. We have observed how from the scratch we can take a data and we can deploy at least at the final stage a classification model. I hope this was useful for all of you. At least the basic concept must be clear for all of you now, that how a simple classification model is built with real data. Let me know if you have any feedbacks, any comments, or any feedback or any queries for the session. Thank you very much for your valuable comments and feedbacks. One error in line 2 you are getting, that is incomplete input. Okay, some portion is missing in your case. Can you just share your screen? Let me check. I think one portion is missing in your writing. That is why it is saying incomplete input.
My decimal is only 0.8. Accuracy is 0.8. Is that okay?
Yeah, no problem in that. It will give different outcomes for all screens because the initializations on all CPUs will be different.
Yes.
by default conditions as you studied in theory, na? So it start with some conditions. So on different
Okay.
initializations, it may have different conditions by default.
Now I got the final one. Ma'am, you said decision tree. Is it complete with this, or we have just checked the accuracy of the model?
We have just checked accuracy of the base model right now with default
Okay.
parameters only.
Okay.
Furthermore, in advanced engineering, what you do is you do hyperparameter tuning with your model. So in that
Mm-mm.
case, you just try to optimize your model in such a manner that it can understand your specific data in a better form and it can give you improved accuracy. We try to get it close to 100 basically. So that is
Okay.
advanced engineering further. That is hyperparameter tuning process.
Okay. Maybe I'm wrong, but I want to clarify this. Actually, when she was presenting about the ma'am was presenting about decision tree model, I was
Hmm.
imagining that uh, you will get lot of the predicted variables. For, like our target variable is heart disease, right? So
Right.
maybe I expected we'll find like a tree, and in the tree all these things will come. So
That you
what
can plot
what is that?
actually. For that, you can create specialized plots. That also is
Okay.
possible. Currently, we are just seeing the outcome only. We are not plotting our tree. But you
But
can plot
that is
also.
our objective, no, ma'am. That is our objective, ma'am.
You want
That
to plot?
no, my question is how do I know now what are the predictors which we have identified with this model? That is my question.
You basically work on accuracy. When you deploy your machine
Okay.
learning model for classification, you try to improve accuracy. That is your final objective. If your
Okay.
accuracy is close to 100%, means your model is performing well in that case. And that
Okay.
100% should be on testing data set mainly. Like we have done it on testing data set. Na comparison we are doing on testing data set. So
Okay.
generally we compare, you might have heard about overfitting and underfitting, ma'am have discussed that day.
Yeah,
So
yeah.
we generally need that your model behaves well on training as well as on testing data set. On both, it should get higher accuracy. As high
Okay.
as it goes, better your model is.
Okay. Okay.
Any other queries if we need have, let me know. Okay, thank you very much. I got the output. That is great. So I hope all of you are working fine till now. And tomorrow we'll be working on one more case study that will be regression analysis. Yes, lots of error will come definitely because you are doing it for the first time. So errors are a representation of learning process here. So don't worry about error. As you practice more, you will get to know your programming language well, and that will bring you more confidence to deploy models also. Can this ternary of prediction accuracy be plotted? Yes, we can plot this. Generally, we prefer this in the form of confusion matrix. That is one of the parameters we have in classification model. So confusion matrix generally comes like more like a heat map form. And there you can see how well your outcomes are being predicted. There are like unlimited scopes further also. You might have heard about precision, F1 score, sensitivity, specificity. These were the techniques for evaluation of model. All of them we can plot separately. For some of them, just values are available. For some of them, you will find exact graphs also. So different possibilities are there. Deployment model for research. We cannot say that a particular model will work for certain research. That is never predicted in advance. We just do trials with multiple models generally when we go into research. Sometime your base models also work fine. That depends on quality of data. But sometime when you have very complex data, that is more common in case of healthcare variables, they generally are coming with some complex variations depending upon how parameter variations for patients are going on. So in that case, majority of time you have to go with either high end models, like stacked models are there, ensemble learning models are there, Or sometimes you do hybridization of model, sometimes you do optimization of model, sometimes you do rigorous hyperparameter tuning of model. Like, there are unlimited things to do when you enter into core research. So in the beginning, no one can predict that only this model will work fine. To researchers also, we advise always that whenever you are listing objectives of your research work, never ever mention about specific model that I'll deploy this model, because you never know whether that model will work fine with your data distribution or not. So you keep it open. You just write your objective that we will imply machine learning. Do not mention a model. Do not write that I'll apply decision tree, I'll apply random forest. Just keep your objective open, that I'll deploy machine learning to classify my this particular variable, or predict this particular variable, and then you keep it open to try multiple models and you see which one is going fine with your data distribution. So that goes with your different data variables generally. I hope I could help you on this. Okay, great. So we'll meet with one more case study tomorrow, and we will learn about regression analysis over there. So be on time again, and we'll have a lot to learn in coming sessions further. Thank you very much for your patient listening today. We'll meet again tomorrow at 6.